In part 1, we introduced the quadratic equation and the parabola it creates, and we learned how to find the vertex, which is the lowest or highest point on the parabola. In this video, we're going to learn how to find the roots, which are those two purple points. Those 2 points are where the parabola crosses the x-axis. In other words, that is where y equals 0. Each of those purple points has a y-coordinate of 0. So let's consider our quadratic equation. We have y equals x squared plus 5x plus 4, and we want to find the value of x when y equals 0. And the question is, how do we do that? How do we solve this equation here for x? Well, there's 2 methods that we'll go through. The first one involves factoring. So we're going to take this polynomial on the right, and we're going to factor it. If you recall, that means we're going to split it up into 2 pieces, x plus smiley face times x plus heart. We covered factoring in the polynomial videos, so feel free to check those out. And as we learned in those videos, when we multiply our 2 factors together, we get our polynomial at the end, and we know where each piece in that polynomial comes from. Our x squared comes from multiplying the first pieces, which are 2 x's. Our plus 5x comes from o plus I. That's multiplying our outer pieces and our inner pieces and adding them together. And our 4 comes from multiplying our last pieces together, which are our smiley face and heart. Now, let's look at our first pieces. X times x leads us to our x squared. That's usually the easiest part. But now we need to figure out our smiley face and heart. And those 2 numbers multiplied get us to 4. So we need to find which 2 numbers multiply together get to 4. And there's a few options. We could have 1 times 4, -1 times -4, 2 times 2, -2 times -2. So let's try out these options. Looking at our first option, if we put in 1 for smiley face and then 4 for our heart, we just need to check if our o plus I matches our polynomial. So in this case, o would be 4 times x, I would be 1 times x, that equals 5x. So that means we have our correct factors, and there's no need to check the others. And you can always use the FOIL method to confirm that our factors multiplied lead to our polynomial. So now we have our 2 factors. Let's rewrite our equation. So we'll have 0 is equal to x plus 1 times x plus 4. So we're 1 step closer to finding x, and x is going to be a number. So essentially right here we have a number times a number. X plus 1 is a number, and x plus 4 is a number. And what this equation is saying is that we're multiplying 2 numbers together, and we get 0. Well, if you multiply 2 numbers together and you get 0, then one of those numbers, or both, have to be 0. So let's consider if x plus 1 was equal to 0. What would this equation look like? We would have 0 on the left side, and then 0 times x plus 4. Well, x plus 4 is just a number, so 0 times a number just leads to 0. So we'd have 0 equals 0. We would have a true equation. And that's what we want to do with any equation. At the very beginning, we wanted to figure out what value of x makes this equation true, so we could have 0 on the left side and the right side. This goes back to our video on what is an equation. And each step that we're doing is trying to make the right side a little simpler so we can figure out what value for x will make the left side equal to the right side. And here we see that if x plus 1 is equal to 0, then the left side equals the right side. So we can subtract 1 from each side, and that would lead to x equals -1. So if we plug -1 in for x right here, that first factor becomes 0. And then we get this situation here, where we'd have 0 times x plus 4, which equals 0. And so our equation would be true. And we can say the same thing for x plus 4. If x plus 4 was equal to 0, then our left side would equal the right side. And in this case, subtracting 4 from both sides, we would get x equals negative 4. And you can check that as well. That negative 4, you can substitute right here, and you'd get negative 4 plus 4 equals 0. So our solution, negative 1 or negative 4, you would substitute that into both spots. But the important thing to notice is that one of those spots is going to be 0. And you could substitute negative 1 or negative 4 in our step above, and you would still get 0 equals 0. But our line down here, where we have our two factors, is just easier to see. And why is it that we have two solutions? Why do we have x equals negative 1 and x equals negative 4? Well, as you can see with our purple points up here, there are two spots where our parabola crosses the x-axis, negative 1 and negative 4. So let's summarize what we did to find the roots. We'll call this the factoring method. And since we're looking for the roots, our first step was to set y equal to 0. And then we factored the polynomial. So we can see step 1 over here. We set our y equal to 0, and then we created our two factors. You could split those up into 2 steps, but I'm just writing it as one. And once you do this, you look at our factors, and you find the x value that makes each factor 0. And that's what we did right here. And again, if you found this work here confusing, I encourage you to check out the polynomial videos. Once you've mastered factoring, this method is pretty straightforward. But assuming that you understand factoring, let's try one more example using this method. Find the roots for y equals x squared minus 2x minus 35. Let's break down this problem piece by piece. So it looks like we have a quadratic equation here. How do we know that? Well, it matches our general form of y equals ax squared plus bx plus c. So this is a quadratic equation. A quadratic equation creates a parabola, and the roots of that parabola are where y equals 0. Okay, so let's start by rewriting our quadratic equation. Using the factoring method, we're going to set y equal to 0 and factor the polynomial. So we have y equal to 0, and we're going to factor our polynomial. So we'll split it into our two factors, x plus smiley face times x plus heart. And our first pieces are x and x, and so multiplied together, they get to our x squared. And now we want to focus on our smiley face and heart. When we multiply those together, we get negative 35. So what two numbers multiplied get to negative 35? Well, 5 times 7 is 35, so we can just make one of those negative, and we get to negative 35. So the 5 could be negative, or the 7 could be negative. Are there any other numbers we could multiply to get to negative 35? Well, there's 1 times negative 35, or negative 1 times 35. So we've got a few options here. Let's go ahead and start testing them out. On our first one, we'll plug in negative 5 for smiley face and 7 for our heart. As we covered in our polynomial videos on factoring, It doesn't matter where we put the -5 and the 7, since our first terms here are the same. Now checking our O plus I, we would get 7x plus -5x, or just -5x, and that equals 2x. Well, we're looking for a -2x, so that is not correct. These are not our factors. Let's check the second option. Plug in a 5 for smiley face, and a -7 for heart. O plus I gives us -7x plus 5x. That equals -2x. And that's what we wanted. So we found our two factors, and we don't need to check the rest. All right, let's rewrite our equation, simplifying it now to x plus 5 and x plus -7, or just x minus 7. So now that we've set our y equal to 0 and factored our polynomial, our second step says to find the x value that makes each of our factors 0. So x plus 5 could be 0, or x minus 7 could be 0. On the left side, we subtract 5 from both sides, and we get x equals -5. And on the right side, we can add 7 to both sides, and we get x equals 7. If it helps, go ahead and write that intermediate step on both sides. And there we go. X equals -5 and x equals 7 are our two roots. These are the spots where the parabola crosses the x-axis. So if we draw a little rough graph, let's say we have x equals -5 on this side and x equals 7 over here. Our parabola crosses through those points. And why does our parabola open up? Well, because our a is positive. Our a is 1. There's that implied 1. Now this is a rough graph, of course. If you wanted to make it more precise, you could calculate where the vertex is. It might be here. It might be all the way down here. And in that case, you'd have a parabola that looks like this. The parabola is still going through the roots, but it looks a lot different depending on where the vertex is. So you can always make your graph a little bit more precise by adding more points. And now that we've taken a look at the factoring method for finding the roots, we're going to take a look at a second method. Let's consider the general form of the quadratic equation. We have y equals ax squared plus bx plus c. As we've seen, the roots are where y equals 0, so we can replace y with 0, and we need to solve for x. When we use the factoring method, we could factor this polynomial here, and it was easy to solve for x. But what happens if you can't factor that polynomial? Well, then you'd have to solve this equation for x, and it looks a little tricky. We have an x squared here and an x here. Somehow we have to get x on one side of the equation and everything else on the other side. Well, lucky for us, the fancy math folks, they spent some time thinking about that, and they were actually able to work down the page and solve for x. So they discovered that if you have any quadratic equation, the x value for the root is equal to -b plus or minus the square root of b squared minus 4ac, and all of this is divided by 2 times a. And we call this the quadratic formula. And this formula says that for any quadratic equation, if you can identify the a, b, and c, all you need to do is plug them into this formula and you can find the roots. So the fancy math folks, they did the hard work of solving this equation here for x, And if you're interested in learning all these steps in between, there's a video in the bonus playlist where I do just that. But for the rest of this video, we're just going to focus on using this formula. And just a side note before we move on, if you're confused by the difference between an equation and a formula is an equation with only one variable. So using our definition of an equation, where something equals something else, you could say that we have an equation up here and an equation down here. In both cases, something equals something else. However, in our first case, we have two variables. And in our second case, we just have one variable. So a formula is just a specific type of equation where we just have one variable. So if someone asks you, what's the quadratic equation, you would say this one. If someone asked you, what's the quadratic formula, you would say this one. So it's just a little detail, but it's important to understand. All right, let's move on to an example. Let's consider the first equation we looked at. That was y equals x squared plus 5x plus 4. Using the factoring method, we saw that the roots were -1 and -4. Now we'll try to find the roots using the quadratic formula. Let's write our general form to help us out. So we have y equals ax squared plus bx plus c. Remember, we have our implied 1 in front of the x squared. So we see that our a is 1, our b is 5, and our c is 4. Now we just need to plug these values into the quadratic formula. So our x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times 4. And all of this is divided by 2 times 1. Now we just need to simplify this. And first we're going to focus on the items under the square root. There's a lot of operations going on, so how about we bring out our PEMDAS to help us out. We have 5 squared, so we have an exponent in there. We have a subtraction sign, and we have some multiplication. So our PEMDAS says we're going to focus on the exponents first, then the multiplication, and then we'll subtract those two pieces. So let's take this one step at a time. We have -5 plus or minus, and 5 squared is 25, and 4 times 1 times 4 would give us 16. And on bottom, we have 2 times 1 equals 2. That leads to -5 plus or minus the square root of 25 minus 16 is 9. And all of that is over 2. The square root of 9 is 3. So we have -5 plus or minus 3, all of that over 2. And we can separate this into two pieces. So we'll have our first root is equal to -5 plus 3 over 2. And our second root is equal to -5 minus 3 over 2. On the left side, we have -5 plus 3, which gives us -2. And then we divide that by 2 to get to -1. That's our first root. And on the right side, we have -5 minus 3, which gives us -8. And then we divide it by 2 to get to -4. Our work here with the quadratic formula shows that the roots are -1 and -4, and that confirms what we found with the factoring method. So you could think of the quadratic formula as a shortcut to finding the roots, but sometimes it's faster to use the factoring method. If you can look at our quadratic equation and quickly find the factors, then you can go straight to the answer. You don't have to go through all these extra steps in the quadratic formula. So now you have two options for finding the roots of a quadratic equation. You have the factoring method and the quadratic formula. Usually you'll be told which method to use when solving a problem, but if it simply says to find the roots of a quadratic equation, you can use either method. Let's try one more example of the quadratic formula, just for practice. Find the roots for y equals 2x squared plus 3x minus 9 using the quadratic formula. So here we're told specifically to use the quadratic formula. Let's go ahead and write that out. We have x equals negative b plus or minus the square root of b squared minus 4ac, and all of this over 2a. And let's write the general form to help us. Y equals ax squared plus bx plus c. So we can easily see that our a is 2, our b is 3, and our c is negative 9. Remember, our quadratic formula needs to match this general form. So we could think of this as y equals 2x squared plus 3x plus negative 9. So for the first couple problems you work on, I encourage you to rewrite the quadratic formula like this, making sure that the plus signs match our general form. But after a few problems, you'll get a good feel for it, and you'll easily be able to recognize that our c would be negative 9 here. All right, back to our problem. Now we just need to substitute each piece in here. So we'll get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 9. And all of this would be over 2 times 2. So we have negative 3 plus or minus. Now we have to deal with the square root. Remember, we focus on our exponents first, so 3 squared would be 9. Then we focus on our multiplication. So we have 4 times 2 times negative 9. 4 times 2 is 8. 8 times negative 9 is negative 72. And all of this over 2 times 2, which is 4. Our next line, we have negative 3 plus or minus the square root of 9 minus negative 72 is the same as 9 plus 72. And all of that is over 4. Our next line, we have negative 3 plus or minus the square root of 9 plus 72 is 81. All of that is over 4. Our next line, we have negative 3 plus or minus, and the square root of 81 is 9. Now we can consider our two roots. We have x equals negative 3 plus 9 over 4, and x equals negative 3 minus 9 over 4. On the left side, we have negative 3 plus 9, which is 6. And 6 divided by 4 gives us 1 and 2/4, which we can reduce to 1 and 1/2, or we can write it as 1.5. On the right side, we have negative 3 minus 9 gives us negative 12. And negative 12 divided by 4 gives us negative 3. So we can say x equals 1.5 and x equals negative 3 are the roots of the parabola.